Okay, on to problem 3. The values for the relation are shown in the table. Is this relation a function, y or y not? So remember, the question we're asking ourselves if we want to determine if its relation is a function is this. Does every x value go with exactly one y value? And sometimes you can tell this just by looking at the table. Other people might be more comfortable making a picture. So sometimes I make a picture, and let me just show you what I mean. So here are our x's, here are our y's. So for example, the first one says that 2 is going to 8. The next pair tells me that 3 goes to 2. The next pair tells me that 4 also goes to 8. Now, that might bother you that these two x's are going to the same place, but 4 is only associated with one number, 2 is only associated with one number, so far we still have a function. 5 is associated with 1, and 6 is associated with 7. So notice that every x value had only one y value, and so the answer is yes. In the next problem, we're asked to find the domain of the square root of 2x plus 1. Write your answer in interval notation. So remember that even roots have restricted domains. With even roots, we know that the expression under the radical sign must be positive or equal to 0. So we're going to set up that inequality. We know that 2x plus 1 must be greater than or equal to 0. And then we just go ahead and solve. And if we go ahead and solve this, now notice with inequalities you have to be careful. If we ever divided or multiplied by a negative number, we would have to reverse the sign, but notice that in this problem, we never had to do that. And so our solution is the domain is any number greater than or equal to -1/2. And to write our answer in interval notation, it might help first to graph it. So here's -1/2. And the graph of x is greater than or equal to -1/2 looks like this. So it starts at -1/2. It goes to infinity. It includes -1/2, so we're using a bracket. And infinity is always written with a parentheses. Let's try the next one. Find the domain of f of x is equal to x plus 1 divided by x squared minus x minus 12. And write your answer in interval notation. So this is a rational function. And in a rational function, you have to be careful that the denominator cannot equal 0. So we have x squared minus x minus 12, and we know that that cannot equal 0. Well, let's find the values for which it is equal to 0. So we have x squared minus x minus 12 is equal to 0. Again, that's a quadratic. So we can factor it, or try to factor it. This will factor as x minus 4 times x plus 3 is equal to 0. And just as a reminder, after you factor a quadratic equation, to find the solutions, you just make each factor equal to 0. So x minus 4 is equal to 0. That means x is equal to 4. And for the other one, we have x plus 3 is equal to 0. And so that tells us that x is equal to -3. So if x is equal to 4 or -3, the denominator would be equal to 0. And so we have to exclude those numbers from the domain. So this is what the domain would look like. Here's the number line. Here's -3. And here's 4. And the domain would not include -3 and would not include 4, but it would include every other number. And so this is what the domain would look like. And notice that it would come in 3 pieces. This first piece would start at -infinity and go to -3 with the parentheses because we're not including -3. This middle piece would start at -3 and go to 4, again with parentheses because we're not including -3 or 4. And this third piece would start at 4 and go to infinity. And in between these pieces, we put the symbol U, meaning we're going to unite all those pieces together. And finally, the last problem in the almost the last problem in the problem set. Find the domain and range of the function shown at the left. Write your answer in interval notation. So for domain, we're looking on the x-axis at the function. We see it goes from -5 to 3. And notice that on the left, we have a closed circle, and on the right, we have an open circle. So our domain would go from -5 to 3 with a bracket on the left and a parentheses on the right. All right, now let's take a look at the range. Now with the range, remember, we're looking at the y-axis. So if we're looking at the y-axis, it starts here and goes to here. So this is the range of the function. So it starts at 0 and it goes to 2 along the y-axis. Notice that at 0 we have a closed-in circle. In other words, it includes 0. And at 2, this one is open on the right, but this one is closed on the left. And so our range does include 2. All right, it includes it here on the left side. And so there's our domain and our range. And finally, our last problem is about a piecewise function. So given the function f of x is equal to x plus 1 if x is less than -2, and 2x minus 3 if x is greater than or equal to -2, the first thing we're going to do is find f of 5. So we have to pick which of these rules we're going to put -5 into. Notice that -5 is greater than or equal to -2. And so we'll be using the second rule here. So for A, we have 2 times 5 minus 3, or 10 minus 3, which is 7. For B, find f of -2. And again, we have to figure out which rule we're going to use for -2. Now notice that if x is -2, it falls into the second rule also, because that's the rule we use when x is equal to -2. And so we're going to have 2 times -2 minus 3, or in other words, -4 minus 3, or -7. Find the domain and range of f of x. Write your answer in interval notation. In order to do this, well, first of all, sometimes it's helpful to know what a graph of this looks like. So let's just start sketching a graph. Okay. So our domain has been divided into 2 regions. We have at -2 a first rule, and then to the right of -2 a second rule. So the rule to the left of -2 is f of x is equal to x plus 1. So one of the things we could do is we could plot some points just to have a sense of what this graph is going to look like. So for example, at -3, f of x would be equal to -2. At -4, f of x would be equal to -3. We know that this is a line that has a slope equal to 1. And so at -3, we would be at -2. At -4, we would be at -3. We would have a line coming like this. And then we would have a circle here at 2, at -2, because now we're going to use the second rule. And let's take a look at the second rule. All right, so for the second rule, let's get some values. We can plug -2 into the second rule. That's going to give us 2 times -2 minus 3, or in other words, -7. We can plug in -1 to the rule. That's 2 times -1 minus 3. That's -2 minus 3, or -5. If we plug in a 0, we're going to have 2 times 0 minus 3, or in other words, 0 minus 3, negative 3. All right, so let's see what that looks like. So at negative 2, we would be down at negative 7. We would be here at 0, negative 3. This is a line that has a slope of 2. And so our second one would look something like this. So let's first of all talk about the domain. Now remember, the domain means on the x-axis. So notice that on the left side, we had an arrow that keeps on going. And on the right side, we have an arrow that keeps on going. And we had no gaps in the x-axis. And so this function is defined for every x value along the number line. So our domain is all real numbers. Let's talk about the range. So for the range, notice that below, if we look at the vertical axis, this arrow again means we keep on going down. And if we look in the vertical axis, this arrow here means that we keep on going up. And so the range is also going to be all real numbers. In interval notation, all real numbers is written as the interval from negative infinity to positive infinity. And that's the end of this week's problem set.